Hello there, my name is Patryk Wyżgowski, and I'm a machine learning engineer at DeepSense AI. Recently, I was involved mainly in projects that are connected with large language models and RAG, as well as at the connection point between databases and natural language interfaces. Today, we're going to cover some details about GraphRAG. We're going to learn about its definition and its specifics and its general idea, just to build the intuition and so on. So let's have a brief look on our agenda. GraphRAG wouldn't exist without RAG, which stands for Retrieval Augmented Generation. So at first, we're going to have a little recap, so we're on the same page and not to be too fast-paced with our knowledge sharing. As of knowledge, we're going to cover knowledge graphs as a second part of our talk, and how they are constructed, how we can use LLMs to construct them, and how we can use them to augment RAG, to use graphs to enrich the structure and provide a richer and broader context for LLMs during the generation process. We're going to finish with some case studies and benchmarks because there aren't many. This is pretty nascent technology, and there aren't much of benchmarks there. Right, so let's jump quickly to a recap for retrieval augmented generation. As you may know, retrieval augmented generation provides the best of two worlds, which is the world of generation, as we have with LLMs, and also citation. And the general idea is that because the knowledge changes rapidly, and we usually want to interact with our private datasets, we wouldn't like to train the model once again and fine-tune it somehow. Much cheaper would be to use somehow modular knowledge base, and this is what we can achieve in RAGs, usually with help of vector databases, which we're going to cover in a second. Usually, we quote rather than generate the facts in a RAG, so there's a little less danger of hallucination and so on, but you would have to look for the benchmark themselves. The very heart of RAG is a vector database and similarity search, because when we index documents, we embed them as high-dimensional vectors, which are stored in the vector database. And when we have another question to our model, then the question itself is embedded, and then it can be compared, and the algorithms for similarity search can be employed at this stage. For example, cosine distance and so on. But because this deep talk is not necessarily fully concentrated on RAG, I cordially invite you to check out the blog posts from my colleagues and the YouTube counterparts of these blog posts, which are deep talks, because they will provide you with rich understanding of RAGs, as well as pretty nice example of a use case, which is small language models employed to work with RAGs on smaller devices when you're limited with resources. All right, let's understand what the knowledge graphs are and how they will be employed and useful for us in a moment. Basically, let's think of a set of interconnected objects. They can represent actually anything, and the objects or nodes or entities, if you prefer, they're connected with relationships. And what is usually done here in knowledge graphs, both nodes and relationships are endowed with some properties. For example, descriptions, summaries, and so on. This is a little hint. Where is the place where large language models can be used? Because of these descriptions, summaries, properties, you can use them, but we will learn about it soon. So now you can see a small knowledge graph where you represent the article and its authors, the properties of articles like the title and their how it's related by a relation of having a sentence with sentence itself, and so on. I hope that the idea is clear and good enough for now. But usually the in-memory processing or actually storing of the graphs is not necessarily possible, or it's too resource consuming. Sometimes you have a pretty large graphs and you don't always want to have the entire graph there. You can even have some distributed databases. So let's have a look on some providers you have for the knowledge graphs and for the graphs themselves, and they can be kept in graph databases. One of the most popular is Neo4j, of course, but it's not. We're not limiting to Neo4j only. You can see other providers like AWS Neptune, dgraph, Elasticsearch, OrientDB, DataStax, and OntoText, which is quite peculiar because it follows a different paradigm. It uses RDFs rather than property graphs, but I cannot go into many details because this is not the topic of our talk. So now with all this knowledge, we are ready to attack the concepts of GraphRAG. As I've mentioned, we want to provide richer contexts for the generation process. And at the same time, we want to somehow limit the context so we don't go into this particular scenario of a model getting lost in vast amount of text. So GraphRAG itself is going to leverage structural information across entities to enable more precise and comprehensive retrieval. It will capture relational knowledge and facilitate more accurate context-aware responses. And this is the actual goal of GraphRAGs. We will just harness this knowledge and provide contextual understanding and improve the accuracy. But you'll see it on the benchmarks themselves. There are several scenarios there. You may wonder why you have two different knowledge graphs in the input here. The difference comes from the fact that the way people and models create structured knowledge graphs and how they structure knowledge differs. But you can still use both. You can actually even combine the two graphs and employ them in the process. But still, this is what I wanted to emphasize, the way how a SME, I mean subject matter expert, and a model, how they will structure the knowledge and create the entities and the relationships, it will differ. So the GraphRAG is going to allow us to, in a case of LLM-based knowledge graph, and not only, to extract the entities we have in our question within our graph, and then apply some, let's call, graph algorithm to get the related nodes and the relationships, and of course the properties and the metadata we have there. Why I have mentioned graph algorithms. For now, the most common implementations in papers or blog posts are mostly about, fanning out the neighborhood around some node. But you can even use graph neural networks to somehow give you back these nodes and then provide them to LLM Usually the results are flattened, as you can see here, just a string representation of the nodes connected by relationships in a graph. Okay, so there is one paper which is less than 2 months old. It is a graph retrieval augmented generation, a survey, which compares many approaches to GraphRAG, but we have a nice comparison between vanilla or naive RAG and GraphRAG. I would like to do some interruption here because GraphRAG is a pretty new term. It's been there, the concept of using graphs and RAG together, it's been there at least for a year, but only with Microsoft's paper about GraphRAG, there was a boom with interest about this particular approach. And the name itself, GraphRAG, also comes from this particular paper. But in this presentation, and actually in my private understanding of this thing, I will think rather generally, not limiting myself to a particular framework. All right, so when we look on this example, we are going to notice something. So for the LLM and direct LLM responses, they're pretty shallow and they lack some specificity. And for the RAG itself, okay, it retrieves the information. It does really better than LLM itself, but it struggles to emphasize the relationships of influence, which is actually the core of the question. So GraphRAG actually mentions the entities and relationships explicitly, and it enables precise answer by retrieving relevant structured information. As I've mentioned, I prefer to use GraphRAG for all the techniques that employ graphs and RAG. So you may come across some hybrid architectures that use both knowledge graphs and vector databases. And actually, it's pretty common setup. I think that most of the blogs I've seen, blog posts, are using this scenario, both from Neo4j and other authors. So I will also mean GraphRAG in this particular scenario. And one of the papers I've mentioned actually does similar thing because they define the GraphRAG framework in its full generality and glory, but it's much broader than the topic of our talk. All right, so now let's have a look on some dangers of LLM-based knowledge graph extraction. And one of the danger was that I have omitted the definition of LLM-based knowledge graph extraction. So you basically use an LLM to extract the knowledge graph, which means finding the proper entities, naming the relationships, providing them with proper summarizations and descriptions, and so on. That would be it. So let's have a look on some dangers of such knowledge graph extraction. We can observe it even manually. So this is example which is based on some posts from Neo4j, and it uses LLM. I believe it was GPT 3.5 to create a knowledge graph about Elizabeth I and the English royal family. But in this entire family tree, there's also Elizabeth Petrovna, which was a Russian empress, who was a Russian empress. And she was related to Peter the Great. And you can see also you have Tsar Peter the Great here and Elizabeth Petrovna as separate entities. So basically, we come across some problem, which is called lack of entity resolution. Of course, there are some algorithms and methods to deduplicate the information somehow. And I think you can find some of them in the Neo4j GenAI stack, but there are many separate techniques for named entity recognition and entity resolution. There is even some service called Senzen, I believe, that offers you similar thing, but as a service. So basically, when we would have a look on one of the nodes and its neighborhood, actually the part of the neighborhood about Peter the Great, you can observe some more dangers. You have cyclic relation of being a parent of one another. Actually, we're going to have a look on it itself. So let's have a quick demo. All right, so I think you may recognize the very same graph from our presentation. And now let's have a look on some questions. You may see some of the normal, of the standard question you would have in this notebook provided by Neo4j, but then we would like to attack this problem of entity resolution and so on, and cyclic relationships. So we have a question about the family relationship between Elizabeth and Peter the Great. And you actually have a proper answer that Elizabeth is his daughter. But when you ask the question in a different manner about asking if Elizabeth is parent of Peter the Great, you can have the positive answer. But if you paraphrase the question once again, or change the order, then you still have the wrong answer. Of course, we can provide some more context with chat history to our question, but still, it's not that easy. When we specify about different node we have in our graph, which wasn't just Elizabeth, but Elizabeth Petrovna, it's much harder to do similar mistakes as we've seen a moment ago. So this was the approach of what I would say local GraphRAG in our demo. Why I mention local? Because this locality comes from finding particular entities and their neighborhoods and so on. But what is outstanding in the world of GraphRAG is this paper, which brings a possibility to answer some general and global questions to your dataset and to your private dataset. So basically, baseline RAG struggles to connect the dots. It has problems with understanding some multi-hop questions, and the holistically understood semantics that is there, it's hard to grasp for baseline RAGs. For GraphRAGs, like local GraphRAGs, it may also not be that easy, as you may see in a moment in our demo, but still, this approach for globality brings the best out of GraphRAG. So what we're going to do is still construct a knowledge graph, but also we're going to create some communities for the nodes. So basically a community and communities within a graph are the partitions of the graph, so they don't have the interconnected parts. So the process we have in this paper looks like this. We have several summaries. We have several runs of the Leiden algorithm that will create the communities and then create some answers at the level of communities. And finally, globally. I've mentioned the Leiden algorithm, so let's have a quick look on it. It first moves the individual nodes from one community to another. In this scenario, it just gives it a color, because at first everything is in a single partition. Then it is refined, and finally we have some aggregate network around here. Afterwards, the communities that are there just represent the nodes, and they are merged into like a single nodes and single entities. Then we just continue the process for the entities. Sometimes they don't change, and if there are no further improvements that can be made, the algorithm stops. What is important there, the communities are usually related to particular concepts or topics, and we will observe it in a moment in another demo, which is Deeptalks as a knowledge graph. So I've created a knowledge graph. This one includes the chunks of the documents. The documents are actually extracted with Langchain. They are YouTube transcripts of our Deeptalks, and not only Deeptalks, even more videos from the DeepSense YouTube channel. We even have the office opening, like new office opening video, and I will mention in a moment why I thought about this particular video. Still, let's have a look on some cleaner perspective without the chunks mentioned there. You may see that this graph is not fully connected. It has some separated parts and some little subgraphs that are there. This is probably one of the root cause for how it works with this kind of data, but we'll cover it in a moment. Okay, so before we jump into the demo, let's have a look on some numbers. So for this graph and Neo4j plus Langchain approach, I've used two models. So one knowledge graph was extracted with GPT 3.5 Turbo, and another one was GPT 4o Mini. So you can see that there's a difference in kind of nodes you have here. This is the number of relations that are there for a particular node. Obviously, large language models and AI are pretty high there, but as you can see, there are pretty surprising topics like Flutter, which also have many connections. Of course, there is a lack of entity resolution. So LLM and LLMs actually are separate nodes now, but when you sum them up, you may notice that LLMs are the top kind of node. For the GPT-4o, it differs a bit, but you may notice that some of them are still there. For the relationships, it's a bit different because I think that the ones you have with GPT-4o are more general, but still, I just wanted to glimpse over that. I did some manual work, but Neo4j offers a pretty good service for your knowledge graph builder, and you can just put some links to your texts, and then it will be extracted and created. Additional example of where it was used is Mahabharata chatbot, and it is a chatbot which is powered by a knowledge graph that was created on some Indian texts. All right, so let's jump into some demos. So we had some comparison of two models and two knowledge graph based on models, and this is what we will do here. So there was this video on the opening of Warsaw office, and there was a comment about a nice drink there. And both a chain, I mean Langchain chain, using structured retriever, which uses graphs, and unstructured retriever together answers correctly, and so does the variant of simple RAG without this knowledge graph retrieval. And in case of GPT-4, we still manage to get sensible needle in haystack answers, because this is this kind of problem. We have a large corpus of text, and then we just want one precise thing, and it happened in just a single chunk of transcripts, I believe. So it's quite unique. This contrasts with some capabilities of Microsoft GraphRAG, which was quite surprising. I've used GPT-4o Mini for the creation, and okay, this one worked well. It managed to answer about welcome drinks, but still it missed the deep sense part. And GPT-4o Mini with the question rephrased, so I tried to give some hints about what particular words we're going to use. It failed to answer the question. When I tried to do the same in local mode, oh, here is the difference. The local mode was used rather than global, and the global uses summaries. Still, let's jump back to some more examples. The GraphRAG is famous of being able to answer some general questions or some questions that are like multi-hop questions. They use multiple stages and so on. So I've asked about the providers for the most popular classes of models that are there, and it was for the structured retriever and the structured retriever. It was done in both cases. Let me scroll. And as you may notice, for the smaller model, it is quite shallow answer. For the unstructured retriever, it actually misses the point. When we attack with GPT-4o Mini, it actually has a chance to respond quite sensibly, but still it's not the precise answer. We may want to help with providing some precision and use the previous response to answer. Here we can see the textual representation of our search through the graph. And finally, we have the answer about particular language models. But unfortunately, the smaller model, let me modify it. The smaller model mean that the models are not explicitly mentioned in the provided context. The larger one just did well in the task and matched the proper providers for the models, which is good. And I think that the same holds for the Microsoft GraphRAG. There are two versions of a model here. One is using GPT-4o, and it mentions the proper providers there. All right, let's jump quickly to benchmarks. But we need to switch. All right. So basically, the experiments with knowledge graphs are pretty fresh, but you mostly have case studies and case comparisons than the actual benchmarks. This is an example of using writer knowledge graph model and the RAG strategy that managed to decrease the response time and to bring the average score just by several percent points. And for the benchmark of other studies, when it was employed in some business-related questions, the knowledge graph allowed to actually do great because it allowed to increase and improve the accuracy by 3 times on average, which is actually really great. There is also another paper about introducing this kind of solution into production, and it was done at LinkedIn. This is the overall idea. It was related to customer service, and of course, beyond some actual win with the metrics, we can see that like the standard metrics, we can observe that it allowed for almost 30% decrease in resolution time, like median resolution time, which is great. Right, so let's have a quick summary. GraphRAG allows to use knowledge for spanning across several documents, and it will allow us to enrich the context. Despite its power, GraphRAG isn't always the best choice for smaller data sets which have single facts. It's not necessarily going to be go-to method, but for the rich interconnected data with vast amount of entities and relationships, it's probably going to outperform RAG. In our case, in case of Deeptalks dataset, this is rather the second case or some hybrid, because there are many concepts, but they are separated because mostly the chunks just were related to single topics rather than interconnected. And this is another part of GraphRAG success, because when you have documents, now you can find the concepts even between the documents, how they are related, not necessarily just on a single document level. Still, the knowledge graph construction using LLMs is costly, and so is human-based. But the community and Microsoft researchers are working on reducing this cost. Thank you for your attention. It was a pleasure to talk about GraphRAG to you. Thank you.